which replaces the electric motor. This hydraulic motor can work as a pump as well as a motor. Please note that electric motor also work as a motor or as a electrical generator. Similarly, here the hydraulic motor can work as a pump. That means you can suck fluid and pressurize fluid from this one to another. For example, if it is working as a pump, this device, during that time, in the reservoir, you have hydraulic fluid. Hydraulic means, we know that hydra means water in Greek. Hydraulic means talking about water based, correct? Water as a fluid which can be used. So we call hydraulics. So but many times in actual system, many places we don't use water. Instead of that, we use oil. We know that water, if it touches with especially ferrous, copper, all those things, moisture with the water can react and create ferrous oxide or copper oxide. We call rust. It can damage the parts. So that means many times if you don't want damage parts, instead of using water, you may use oils, different oil, correct? Natural oil, synthetical, some oil you can use. So that's what we use in many places instead of water. So when I say hydraulic, automatically it should be water based, but oil based also we call hydraulic only. Okay, so the reservoir, there's a fluid reservoir where, for example, an oil is there, correct, at a 1 bar pressure, at correct atmospheric pressure at sea level. That will be sucked by this pump. Pump sucks the oil and pressurizes from 1 bar. It can to anywhere, more than greater than the pressure will be so stored pressure. I can say stored pressure will be greater than 1 bar. Correct, because that means the pump sucks, pressurizes, and stores in a accumulator. They call accumulator. This is a storage device. This reservoir, please notice, is an open reservoir, a container. It is not sealed. Correct. It is if you take a drum, the top side is open. There's filled with oil or water. So there's a 1 bar pressure is acting. We call this as a reservoir. From this, the pump is going to suck the oil and pressure. This is the pump. Hydraulic one, I say HP. Pressure is stored in another this one. Here the pressure high pressure. Correct. You can set the pump. Can you using pump? You can press any pressure. So that's a high pressure accumulator. Okay. Whenever engine is running, correct, the engine will be driving the vehicle. Vehicle is moving. Simultaneously, it can drive the pump, the hydraulic pump, so that the fluid at 1 bar pressure will be sucked by the hydraulic pump and it will be pressurized. For example, 100 bar. Example, it can 10 bar, 20 bar, depending on what you want. Later, we'll see that when we talk about hydraulic hybrid vehicle, design, all those things, we'll talk later, modeling, simulation, how to design something. We'll see later part that time. So 100 bar, that means the pump pressurizes and stores the same fluid at 100 bar plus inside a high pressure tank. Okay. Now, suppose suddenly your vehicle is moving, correct, in a plain road. That time the engine is driving. Some part of the engine power is used to drive the hydraulic pump, which sucks the fluid and stores in high pressure. Now, suddenly I see a uphill, correct, a gradient. I need more torque. What I do? I will disconnect the pump because I will see that the hydraulic pump will be made to work as a motor. Okay. So that means the high pressure fluid stored in this one will go inside and it will drive and generate torque. Correct. So the motor torque is coming. I said, sorry, engine torque TE. This I say that HM, hydraulic motor torque, both will be added. Whenever I go to gradient, if I want additional torque, which is not sufficient provided by engine, I will make this hydraulic pump or motor as a hydraulic motor. That means it requires high pressure fluid, which this high pressure fluid stored in this will be redirected and made the motor to rotate. During that time, the pressure will be converted into mechanical torque and the fluid will be again stored in the reservoir. The pressure will be dropped to 1 bar or something and it will be again stored in the reservoir. Okay. So from the reservoir, 1 bar pressure, I pressurize using engine power and store it in high pressure. Okay, normal condition. Whenever I want power, same hydraulic pump will be made as a work as a motor. So the high pressure fluid will be driving the hydraulic motor, which will provide additional torque to the wheels along with the engine. So this is how the hydraulic hybrid vehicle works. You can see that literally functionality wise, the hybrid electric vehicle and hydraulic hybrid vehicle both are functionality wise same. Only thing is here, instead of using electric motor, I am using hydraulic motor, which will augment the torque provided by engine. So the kinetic, how it works, the kinetic energy is captured during the regenerative braking of hydraulic engine. Another thing is, engine power may be used to suck the fluid from the fluid reservoir by the hydraulic pump and store it, or when we know that whenever you apply brake, regenerative already we saw in the hybrid electric vehicle, the motor will be made as a generator, the wheel will be driving the generator. So generator put electricity, that's electricity will be stored in the battery, and the battery power will be used again. The generator can be again made as work as a motor. Whenever you need torque, additional torque, so the battery power stored due to regenerative braking or by split power means engine power itself used for driving the generator. We know that in the Prius, the motor one generator, correct? Or there are two motor, MG1, MG2. MG1 most of the time works as a generator, taking power from the IC engine and stores the electrical energy in the battery. Generator like this one. Similar to the we can do that. Apart from that, the hybrid electric the electric vehicle also, the whenever we apply brake, instead of wasting energy in the brake shoes through the mechanical friction, we connect the motor in a generator mode. So the generator will be driven by the wheels. So it produces electricity and store. So similarly, in hydraulic hybrid also, the whenever apply brake, that regenerative braking torque or energy will be used to drive this pump, and so that the fluid will be pressurized. Fluid will be pressurized during the regenerative braking or by engine itself. That depends upon the vehicle design. Okay. So main thing is it is also recovery hybrid or electric hybrid. Both will be recovering the braking energy, which we call the regenerative braking. That is going to improve the few up to 5%, correct? Energy can be recovered, maximum up to 5% of the vehicle energy can be recovered using regenerative, whether hydraulic it is does. What are main components of the hydraulic hybrid? You have a low pressure hydraulic reservoir. Let me clear this, you can see it. This is the low pressure, because I told you the fluid is stored at low bar, 1 bar pressure, correct? Yeah, oil. Mostly, generally, nobody uses water because it's corrosive. It oxidizes metal parts. Because many times you use iron base, correct, parts in a vehicle where water will corrode from this one. That's why we use oil. Okay, so yeah, reservoir containing oil at 1 bar, low pressure 1 bar. Then you have high pressure accumulator. This will be sucked. Then you have hydraulic pump, because the same component can work as both ways. That is possible. Okay, and same they will work as a motor also. There are no two components, only one component which can work as a pump and motor. That is possible. That is like this. Then during the deceleration of the vehicle, hydraulic pump is actuated. This will work as a pump and moves the fluid from the reservoir low pressure to high pressure like this in the direction into the hydraulic accumulator, stored at higher than 1 bar. Definitely it will be 50 bar, 100 bar, this one. Please note that higher the fluid pressure, higher pressure, I can say that fluid pressure, more torque can be generated. More torque can be generated. Torque in hydraulic motor, correct? Hydraulic motor, you are supplying high pressure fluid HPF, this direction. So that time, what will do? It is going to drive the motor. The torque is proportional to pressure, correct? And again, the speed of the hydraulic motor, correct? The speed, I can say that yes, is proportional to flow rate, FR. What is the rate at which the high pressure, 1 liter per second, 10 liter per second, higher the flow rate, going to the motor, the speed will increase. Similarly, higher the pressure, more torque will be generated. This is basic principle, just note down. Okay. So then the energy stored in the compressed fluid, that is in the accumulator, will be used to drive the vehicle whenever needed. Correct. Same as charging the battery in a hybrid electric vehicle, ready to power the hydraulic motor to propel this one. In case of here you use electric motor. In this case, the hydraulic motor will be used additionally. Correct. Apart from torque from engine, this hydraulic motor also provides additional. You can just add it. That is the net torque. I say T net at the wheel. Okay. Stored energy in the high pressure accumulator can be released to power the hydraulic motor, which in turn can propel the vehicle. That's what I already told you. Okay. Now, when we talk about hydraulic hybrid, okay, in hydraulic also you have series hybrid also. Right? This is a parallel hybrid. Please note that this is a parallel hybrid. Okay. So motor is the engine is providing, motor also. Anytime you can decouple. Engine alone can drive, engine plus motor alone, but depends. Correct. So this is like a parallel hybrid. And in series hybrid, you will see that the vehicle is driven by hydraulic motor only. Engine is never coupled in series hybrid. We know that series electric hybrid, engine drives the generator. Correct. So engine, thereby electric generator EG, correct, which is connected to electric motor EM. EM only always drives in the series hybrid. Similarly, in hydraulic hybrid also, note down this configuration, how it works. You have low pressure, that means at 1 bar pressure there is a fluid. That fluid will be sucked by the pump, hydraulic pump, and that is driven by engine. This engine drives the hydraulic pump. The fluid is sucked from 1 bar to maybe, for example, 100 bar, which in turn will be given to electric motor, the hydraulic motor, and which can drive the wheels. Okay. So if you are applying brake, that time this also can work as a motor. So that regenerative braking also possible. Please see that the vehicle is driven by hydraulic motor only, and sometimes it can pump. Correct. And this one to collect during regenerative braking alone, this motor will act as a pump and additionally suck this one store. You can see that there are two parts. From the low pressure 1 bar, normally this will be pressurized. During regenerative braking, this also can store this one. Okay. And when wheel is driving this pump, okay, and it sucks the fluid and stores. So this is called series hydraulic hybrid vehicle. In series hybrid, conventional transmission, driveline replaced by hydraulic transmission. You can see that this is what the whole thing. Energy transfer from engine to drive the wheels through the hydraulic motor. Again, only hydraulic motor only going to drive, similar to electric motor in case of series electric hybrid vehicle. Okay. In series hybrid vehicle, component again, as we saw that you have a hydraulic pump, hydraulic motor, and a low pressure hydraulic reservoir, high pressure storage. Right. So this high pressure storage, low pressure reservoir where the fluid is stored, and there's a pump and there's a motor, and of course engine is driving. Correct. Being hybrid means definitely there's a IC engine, no doubt. Okay. Then the third one is the last one. I just wanted to please note that same thing. This hydraulic series are parallel. This can be replaced by pneumatic also. Pneumatic hybrid. That also people have tried. Please see that pneumatic means instead of using hydraulic, that means liquid, we are going to use gas. That means nothing but air. Air will be sucked and stored in a high pressure, and instead of hydraulic motor, there will be pneumatic motor. Pneumatic motor will be driving grid. Sometimes people call it air hybrid. It is almost similar to hydraulics. Only thing is hydraulic motor used by a pneumatic motor, and hydraulic pump and everything will be replaced appropriately. Note down this. If you will find time, we will talk about that. People have tried, but now as such nobody is using. They've all tried all this kind of hydraulic, all this thing. Finally, they ended up with electric hybrid only possible. So that is what we are going to really going to talk more. But of course, we'll see about this also later. Okay. So though hydraulic series, though it is a parallel hybrid vehicle, benefits will be highest in case of vehicle operator stop go. Correct. Then under they tested under EPA drive cycle. They have demonstrated which one the hydraulic hybrids. They were able to increase the fuel economy up to 70%. Why fuel economy? Please note that the vehicle is most of the time driven by engine. Correct. So, but we are going to use less this one, and we will be recovering regenerative braking, hydraulic motors, losses are less. Correct. Hydraulic motor has another advantage. You don't need gear train. There are other possibilities are there. When we see it, we'll see that. So that means gear losses, many things you can reduce in case of hydraulic hybrid. That is why they were able to achieve up to 70% improvement and reduction of emission, because you are not going to buy in the more fuel. They reduce up to 40% in USA EPA drive cycle. So energy recovery in this one during regenerative braking, doing regenerative braking, engine generally operated at max torque condition, or that means mid throttle condition. So why? We know that engine is going to drive the pump and store the convert the low pressure fluid to high pressure, which in turn is going to drive the hydraulic motor. So okay, then more efficient engine can be shut off when needed, especially in city drive condition. What you can do is you store sufficient, like you're charging the battery. Please note that this is nothing but like a battery, correct? When you are driving a highway using excess energy regenerative braking, you store as much as possible high pressure fluid or air inside this accumulator. Once you come inside the city, shut off the engine if needed. If you have something, you will be driving this directly from the high pressure. That means no emission happens. That's what the last point we are talking. Shut down the engine and always try to run using hydraulic motor only. Start, stop, all those things, correct? You know that when you stop the engine, start the engine, ideal condition, maximum emission, maximum less fuel efficiency, correct? IC engine major drawback is a low throttle condition, more emissions, less efficiency, torque production, all these things can be avoided. So that means city condition, signal, stop, start, decelerating, accelerating, all those things for every signal you can run like an electric motor. As we know that hybrid electric vehicle inside city, the electric motor will be driving most of the time, because you don't need very high torque to accelerate all these things. Motor is efficient. Same thing, hydraulic motor will be used. That's what the advantages. The last one I want to talk before closing is what you call a mechanical hybrid or flywheel hybrid. This also people have tried. Here you can see that there's a flywheel. Correct? Flywheel, know that big heavy mass, like a cylindrical solid mass. Already we know that flywheel is there in the engine also. You know that it can be used to store the mechanical energy. Okay, so here you have engine. Again, hybrid means engine, and instead of having electric motor or hydraulic motor, correct? So you will use a flywheel in which energy will be stored. Okay, energy will be stored, and that energy will be used for accelerating vehicle whenever engine torque is not sufficient. Correct? So this fuel is for driving the vehicle engine. Okay. Then mechanically this is coupled to this one. Similarly, from the flywheel, okay, the energy can be transmitted back to the wheel directly as a mechanical energy. You may see here there is a electric motor. This is mainly sometimes used for regenerative braking. Correct? Whenever this one is there, this energy from wheels will be used to drive the flywheel, so the energy can be again stored. Correct? So this works like a battery, high pressure fluid or high pressure air or electric battery, similar to energy. But to electricity then stored or hydraulic fluid or air. Instead of that, the flywheel stores the mechanical energy itself in this one. So this also they tried. The flywheel hybrid don't require any energy conversion, so they are highest efficiency, because if you convert one form of energy another form, store it again from the mechanical to electrical, store it in battery, from battery again get back, convert the electrical energy to mechanical, give it to wheel, double conversion, have a lot of losses. Okay, that is in general flywheel system energy losses due to, but of course the flywheel has to rotate, it should be supported by bearings. Bearing friction makes them less efficient than battery. They have tried, correct? So storing energy for a long time is not possible in flywheel. Battery I can store today, I can stop my vehicle, go away. But in case of flywheel, if the motion stops, immediate energy is lost. And if you make the flywheel to rotate and keep the energy, it need bearing. Bearing friction slowly eat the energy. After one day, something the flywheel come to rest. So that is why that is major drawback of mechanical or flywheel type hybrid. Researchers are working to improve this, make it lighter, all those things. It is still research. They tried, but this is very useful in static applications. Correct? In static applications, energy can be stored in the flywheel, all those things, and not to store longer distance. But in case of mobile, this one like vehicle, all those things, carrying heavy mass, all those things, not advantageous. They cannot store by energy like a pressurized fluid, pressurized air, or electrical battery. So they stopped it. The proposed flywheel would eliminate many of the charging time. All this thing can be there. There's advantages, but again, it is not very useful. We know the one company called Recordo in UK. They have developed a sealed high-speed flywheel type to recover the energy and store the braking, regenerative braking from a flywheel hybrid. They called it a flybus. This company very popular research institute in UK. They tried and they were successful. But use of large and high speed flywheel for mobile application was a major challenge due to potential imbalances, stresses induced mechanical vibration, all these things. So these are all those things they tried, even though many advantages, it is not very useful for mobile application. This is just to give an idea that there are different type. Somebody may ask, what are the other type hybrid? That's why I'm just talking. With this, I close the first section. We have 5 sections in this course. First section about introduction, different hybrid, series, parallel, all this thing, configuration, how the power flows happen between the different hybrids, correct? From engine to power flow diagram, we saw, correct? Engine alone working, that time electric motor will be off. Electric motor alone will be the then series, how the power flow have electric generator, electricity, it is given to electric motor, which drives wheel. Some of the energy goes to battery, again come back. All this thing is saw. Correct. So from the section what I cover, you can expect a full question marks. What I call as 6-7 hours. Okay. So including this. Okay. Now, next section, what we are going to talk about is I think we started. Yeah. Next part, what I am going to talk about is the components of hybrid vehicle. Okay. The components of hybrid vehicle we are going to talk. So what we'll be talking today. Okay. I just want to give an introduction. I will share news sharing because this will be like a regular class teaching. I'm going to share. Okay. So You think like that is a blank, this one. This how most of the portion I am going to cover here afterwards. So we know that when we talk about the hybrid vehicle, specifically electric hybrid, the component layout already we saw. Definitely there will be a IC engine, and it may be connected to EG for motor. It can work as a motor, but if it is a series hybrid, you just work as a generator only, electrical generator. Then you have electric motor. Okay, the electric motor is going to drive the wheels. Okay, so again, parallel hybrid means already we know that you have an IC engine which may be driving the wheels, and you have electric motor EM. I am showing like this because the electric torque TE directly goes, and we have battery, electric generator, so battery, and so from here it goes, and of course, okay, so this is parallel hybrid, series hybrid, okay, and this can be also split power. Parallel means the IC engine, electric motor, combined it goes, and power from IC engine will not go to electrical generator. Okay, but in case of split power, some amount of electrical power will go, mechanical power is going to wheel, electric motor will be combined, correct? T engine plus T motor will be equal T net driving the wheel. In case of split power, some power will be used to drive another generator, electrical generator, which will charge the motor. Battery, and that power can be used back. And of course, we know that this motor also will work as a generator, EG, because for regenerative braking, mechanical energy will come, and this will charge the battery. Correct? So this can charge the battery from engine during regenerative braking. This motor also will become, we can say that already we saw in a Prius, the second motor I can call this EM2, this is EM1 bar, this one. We can do this. Now, regarding this, first thing is we know about how the engine, the parts of the hybrid vehicle works. The IC engine, I think now for the 2024 batch, Professor K. Anand is teaching how IC engine combustion, all this thing is talking. And 2023 batch, already Professor Anand has taken the course, so you know about IC engine. I am not going to talk about this. Of course, we talked about the engine, all those things, some makes of 5 to 6 or 7 class when we talk about introduction autonomous vehicle. Also, I just discussed the engines a little bit, but more already. So, what is pending in hybrid? This one is electric motors, correct? Electric motors working should be understood. Okay, so so electric motor, and the electric motor, we know we are going to see from another 5 to 6 hours or 8 hours. The electric motor needs electrical power. So that means electrical power generally In case of mobile application, it is from battery. It is from battery, and from the battery power comes plus minus. This is given to what you call as a converter. We call as electrical converter. We'll see what it is. Electrical converter will generate the required type of electrical energy. Correct? There are two type of energy, DC and AC. Correct? We call DC power. Other one is called AC power. Right? So battery is a DC power source. That means it provides constant voltage with respect to time, as long as energy is not depleted. That can be directly given to a DC motor. If then it goes to a motor, okay, electric motor. Then many times the energy from the battery goes to a converter. From the converter, it may not go to directly to motor. Before that, there will be a power electronic circuit. Power electronics circuit along with sometimes they call controller, power electronic control circuit. We'll see what it is. Then from there only it goes to motor, electric motor. Okay, so this is how the power flow happens. Here you have electrical power. The electrical power will be converted to the AC power, DC power, which in turn will be given to an electronic control unit or power electronic unit, which controls the voltage. What is job of this power electronic? Controlling the amount of voltage / current supplied to the motor. Supplied to motor. Okay, that. But we know that when we talk about motors, motor needs a specific amount of voltage and specific amount of current to generate specific amount of torque and speed, which is nothing but mechanical power, shaft power or this one. So we will be talking these three things. First we talk about different type of motors. Then we will talk about power electronic circuit and also the converters. And lastly, the energy storage. The battery, in fact, we are going to cover as energy storage. Battery is storage device. Battery is one such device. And other one is battery. Other one is capacitor. Okay, there are two types of electrical power storage device. One is called battery. Other one is a capacitor. In this, we have different this one. Lead acid battery. Start with, correct? NIC, nickel cadmium battery. It came in between, but nowadays nobody uses it. Then now lithium ion, Li battery, lithium ion battery. This is the latest one. We will be talking about this battery, how they work, how the energy is stored, all this thing. Okay, as a separate division. So then similarly, the power electronics, we'll be talking about the transistor, diodes, MOSFETs, and the third one is called thyristor. Please don't worry about it. I am going to talk about separately 3 to 4 hours each one. Okay. So then converters. Converters, we call this a DC to DC, DC to AC. There are two types of converters. We are going to how they work, what is used, how to design, and necessary this one. And then the final is the electric motor. We are going to talk about electrical motors. Okay, electrical motors. When we talk about electric motors, they can be classified as broadly two categories. Please take the notes as I write, because that's why I'm using like a blackboard. You can easily take, because I don't have any slides. Hereafter, you are not going to see any slides for remaining another 35 to 36 hours. Everything will be taught like this blackboard. Please take the notes. Okay, because literally I don't know, because this I'm teaching for last 5 batches, and so I have handwritten note. That's what from that I'm teaching. Okay, when you talk about electric motor, there are 2 type of motors are there: DC motors. Other one is called AC motor. We know that this is called alternating current. Already know that, but anyhow, for the sake of continuity, alternating current motor.
Hello.
Yes,
Sir?
please.
Sir, the notes will be you are going to give, or we can copy these notes only?
You take the notes. I don't have, because I have this what. See, this is what I'm this one. No, same thing only.
Right, sir.
Okay. So if you write, you will remember. That's why I'm asking you. Please take the notes. If you attend, take the notes. In the exam, you remember. Okay.
Sure, sir. Sure, sir. We will take it, sir.
Okay. DC motor, they're called direct current motor. Okay. In the DC motor, there are 4 types. One is called series motor. Other one is called shunt motor. Then third one is called brushless DC motor. Then stepper motor. These are major. Apart from that, maybe special category that you forget it. In fact, there's one called compound motor also. If you're electrical engineer, you would have heard about what you call compound motor. We will see that compound motor. Okay. Out of this, the series DC motor, shunt DC motor, compound DC motor, all these things are nowadays we are not using in electric vehicle. They were used in the initial stages. Initial stage of electric vehicle, these motors were used. Design, maybe 1970, 80s, 90, all those things. After that, now nobody is using. Now, stepper motor also not used in electric vehicle. This is what used in EV. In electric vehicle, we are using brushless DC motor. So we will talk more about this, but of course, we'll talk about series motor, shunt motor, compound motor. Stepper motor, I'm not going to talk. If time permits, we'll see. Otherwise, this is very important. What is the brushless DC motor, how it works, what input we are giving, all this we'll talk. When we talk about AC motor, again, there are mainly 2 types. One is called synchronous motor. Other one is called as induction motor. Okay. So these are the main 2, this one. Apart from that, you will see one more type motor in AC or DC. The 6th one, I just got in mind. One is called servo motor, DC servo motor. And also this is called as AC servo motor. Please note that this servo motor, both AC or DC, are used for control purpose, not for driving the vehicle propulsion. Control purpose only use.
Sir, they're more of actuators, right? Servo
Yeah,
motor.
that's what I say. Control purpose. They are actuators. That's what I say. They are not used for propelling vehicle. Okay, so this we are not doing. Servo motor we are not going to see. We will mainly see brushless DC motor, how it works, synchronous motor, how it works, and induction motor, how it works, design, calculations, power, all those things we'll see. But let me start with basically, when you talk about motor, we definitely would have done course, but still we'll talk about what is the first motor invented was not AC. AC power itself was invented by Tesla, correct? Nikola Tesla, correct? Not Elon Musk, because he is using Tesla name. Okay, okay. Nikola Tesla is a American this one who invented AC power. Correct? He only invented AC power, all these things. He had many ideas, but of course, Nikola Tesla. So to honor him only, Elon Musk is first electric vehicle called Tesla vehicle. Okay, that's different. Okay, AC motor because it came later. The first motor appeared by use was DC motor only. Now industrial drive everywhere, factory, vehicle everywhere, wherever electric motor was there, they were using DC motor, maybe series motor, shunt motor, compound motor. These were there for at least more than 150 years, 100 years, correct? Approximately. The DC Bristol motor came some to 20, 25 years before, correct? Now, okay, the stepper motor also there. Stepper motor also generally used as an actuator, correct? Stepper motor is used as an actuator, or it can drive small amount of torque, correct? Robots, many robotic applications, all those where the torque and power requirement is not in the order of tens of kilowatts, 1 kilowatt, 2 kilowatt, something like that. And this one, they use even stepper motor to drive as a this one, but generally used for control purpose. These three motor, series, shunt, and compound DC motors were initial use. Even now they are using many industry, old industry, go to ginning mill, cotton mill, all these things, which is 50-year-old, still they are running. They are using DC motors, many applications, even now, old factories, but they have a lot of issues, correct? A lot of issues, we will see that. So that means our primary concentration will be on synchronous motor, induction motor, and brushless DC motor. But let us start with what a motor means, how it works, everything we'll see. Okay. Okay. So when we talk about motors, first let us start with the DC motor. The basic principle behind the DC motor working is very simple. DC motor consists of two parts. One is called armature, which is a rotating part, and has a shaft, right? Rotating part with shaft. I can say with shaft. The shaft only we are going to connect the load. Load will be connected physically, mechanically connected for driving or doing work. So then it has another one called field. Okay. So the electric motor consists of two parts. One is called armature coil. Okay. Other one is called field coil. Okay. Okay. Field coil is a stationary part. Please note the coil means copper wire, aluminum wire, some wire, correct? It is not a straight wire like a coil. That's why you say coil. Now, then that means literally a DC motor can be represented something like this for your understanding easiness. Any book, if you see electrical book, you'll see something like this, in which you have this electrical coil. This is called as field coil. And this is called a pole. Electrical pole, or this, there are two poles. I can say this is, there are two. We can see that this one also is another pole. These are the pole pieces. They call it pole pieces. There are two pole pieces. One will work as a north pole. Other one will work as a south pole. Okay. And this field coil works as a electromagnet. Okay. That means works as that means it requires electrical voltage, which in turn produces electrical current, because of the electrical current is flowing, electric current flows, there's a magnetic field is created. Electric current flows, magnetic field is created. We call it electromagnet. This is called as electromagnet. Very simple. You know that naturally also you have magnets, right? Magnets are available in natural form itself, correct? And you can take it, you can shape it. So generally we say bar magnet, right? Bar magnet you can make in fact. Nowadays nobody is going to this one, but initially the magnets are available. Even now it available natural, like a coal, iron, something is available in some places, correct? And it has north and south pole. So this we call a permanent magnet. Permanent magnet now we are making in factory, correct? Take a nickel ferrous metal as a solid bar, round shape, cylindrical shape or rectangular shape, on which you supply electrical power, sudden high intensity apply voltage, there's a current. This creates electrical field, magnetic field. That magnetic energy will be stored inside this bar. It becomes permanent magnet. That's how they're making. You would have seen in physics lab, chemistry lab, where we go to your physics lab and college, you would have seen the bar magnets. Easy level, as a kid, everybody use. So this there, but natural also magnets are available. Correct? Initially, human found as a natural magnet, only permanent magnets. Then only electricity itself came only some 400 years before. Before the people did not know electricity, correct? We will see that later. So it has one coil called field coil, which is stationary. That means this is stationary, it is not going to move this one. Now, if I supply a voltage, which I call the voltage generator, capital A, V, and subscript F means field voltage. That means we are going to supply a DC voltage from a battery. Correct? For example, 12 volts we are supplying. Okay. Now, the coil is made of a copper wire. Correct? Copper wire has a resistance already. I don't know whether I told you in the mechatronics, you are not done, no? Okay, we'll see when it. Anyhow, if we have a coil having a length.
Sir, I think you had covered small portions of this during mechatronics.
Yeah. So,
Later part of the course it was there. Sir.
Yeah, R equal to rho L by A, correct? So resistance of the any wire equal to resistivity of the material. If the copper resistivity, L is the length of the wire, A is the cross-sectional area of this one. The automatically any metal wire has some resistance. That depends upon the resistivity, length, and thickness of the wire. Okay. So that means there will be a current flow. Now I applied 12 volts, and this has so many coils, so many length. I say that the resistance, I say that RF field coil resistance is 10 ohms, for example. Okay. Now, then according to Ohm's law, there will be a current flow IF. IF equal to VF divided by RF. Now we know that 12 divided by 10, 1.2 amps current is going. That means 1 point of the current is flowing from positive of the battery. From here, it goes like this, coil, comes like this, comes like this one. Now, once current is flowing, please note that automatically magnetic field is created. Magnetic field is created by Ohm's law. Sorry, Ampere law. And Faraday, there are two laws. Ampere is a French electrical engineer. Faraday, we know that. Faraday is a British electrical engineer. He invented many things, Faraday law, right? So there are two laws governs the magnetic field creator. How much magnetic field will be created? What will be the direction of the magnetic field? Okay. So when current goes this, it creates a magnetic field like this. Okay. From this will be called where this is created North Pole. From the North Pole, the magnetic flux goes to South Pole. So this is the flux direction. I say that magnetic flux with direction. Okay. So flux are flowing from North Pole to this one. How long it will go? As long as the current is flowing. For example, if I put a switch like this here, correct? This is my switch. At t equals 0, I close it. So current flows, then magnetism. If I open it, the current flow IF becomes 0 automatically. So, but this as the generally symbolically represented by phi, right? Greek symbol phi is the magnetic flux, and I say pi f, correct? So the unit for this is Webers or Tesla. Webers or Tesla, these both units are used. Are the SI, many this one. Many times people say Webers, correct? Like resistance in ohms, voltage in the volts, current in amps, similar to that. The magnetic flux represented by Webers are this one. So how many Webers produced depends upon the phi f. That means I can say that phi f is directly proportional to IF. IF is directly proportional to VF for given RF. Already we know the equation, correct? So already we saw that IF is proportional to VF, correct? RF is already fixed. For example, my field coil has 100 turns. Its resistance RF equal 10 ohms according to R equal OL by A. That means that is fixed. Already you made coil and the thickness, everything, the resistance 10 ohms they decided. So that means if I want more current to flow, I have to supply more voltage. So what is my input? VF. This supply, this is called field voltage. Okay. This is the one part. Okay. Motor needs two magnets. Correct? Motor generate torque due to magnetic repulsion between two magnetic fields. Okay. So now let me use another color. Okay. So then you have another part already I told you, rotating part called armature. Field already we talked. Rotating part is generally represented like this. Please note that armature in DC motor, see any electrical book, it will be represented like this, symbolical. Okay. And it also has a coil. Please note that it is also electromagnet. It also has a coil. Okay. So looks little clumsy. Okay. I can say that again. So again, the armature coil, this is called as armature coil. It is wound. Please note that which is shown in violet color is made of iron material, correct? It is called iron core, and over which I have wound the coil. Armature coil is wound over the armature core. Core is made of ferrous magnetic material on which. So now again we have a voltage. This voltage is called as VA. Why VA? V is represent voltage, substitution armature voltage. This is my armature voltage. Okay. Now you know that this is again we supply. Please note that DC motor needs DC current and DC voltage. Both the VF and VA are DC voltage supplied from some DC. So it can be a battery or a DC power supply. Okay. Now this armature coil also made of wire, copper wire, for example. It has resistance. I say RA equal to again 10 ohms for understand easiness, right? I am applying RA equal to 10 ohm. Okay. So that means I apply a voltage. I say VA is also 12 volt from another battery. So what is my IA? IA equal to VA divided by RA is going to be 12 divided by 10 is going to be 1.2 amps. So there's a current flowing from the positive of the battery. This I call IA, enters inside the coil, and because of that, once the current goes through the coil, which is wound over the armature core, which is made of magnetic material. Yeah, magnet is again for electromagnet is formed. Okay. So that electromagnet, let me use some other bright color. Okay. So this is north pole. This is south pole. Please see that I am circling. Right? North and south pole. Okay. Now, what you see here, I have two electromagnet. One is called the field magnet Other one is called armature magnet. Both will be, magnet will be active only when voltage is supplied. That's why they call electromagnet. It is not a permanent magnet. If I supply electrical voltage, there's a current flow. Both coil produce magnetic flux. One produce phi F, other one produces phi A. This is producing phi A. Okay, so that this one. Okay, so there's a magnetic flux. You can see the light yellow. I don't know whether you're able to see. So it also produces a north through south pole. Okay, so magnetic flux. So that means there are two magnetic field. One is field magnet phi F, other one is phi A, armature magnetic field. Okay, now one thing, please see that as I told that. So this is north pole of the field magnet. Again, armature magnet is the north pole. That's what I showed you. Please see the north and north. Here, south pole of field magnet, and again south pole of armature magnet. We know that if two magnets are there, both the magnets north pole and north pole come together, they repulse. And if the opposite pole, they attract. In this case, what happened? North pole of the armature coil and the north pole of field coil are close to each other. So the magnetic force will repulse. Similarly, the south pole. Now, as I told you, the field coil is fixed on the body of the motor. Correct? For example, Venus, it is generally cylindrical shape. So the field coil is fixed on pole pieces and it is fixed, it is not rotating. That we cannot do. But the armature is put on a shaft. For understanding, by showing a solid shaft, correct? Shaft with the bearings, correct? There are two bearings. So the armature can rotate. So that means due to the repulsive force generated by north pole and north pole of the two magnets, south of this one, the armature start rotating, correct? For example, it rotates in clockwise direction. So this one. Now, when the magnet rotates, what will happen? The north pole of the field magnet will remain, it will not change location. South pole of this one and this one. But the armature is rotated 180 degree, and as it comes this one, the north pole will be attracted by this south pole of the field magnet. Similarly, the south pole of armature will be attracted by the north pole of this one. So you get a new for this one. I will draw it simply here. This is north pole. This is south pole. This is north pole. This is south pole. This is after 180 degree rotation, right? After 180 degree rotation, the magnet aligned like this. Now, the armature rotated 180 degree, it will just stop. Nothing will happen. But you got a rotational movement for 180 degree with a force. We call it torque. Who created that? The field and armature magnet. So the torque produced by motor, for example, I said Tm is proportional to pi f multiplied by pi a multiplied by a constant. I can call it motor constant. What it is, I'll explain later. Okay, that depends upon the core. I told you the field pole, correct? Pole are there, correct? The two pole pieces and armature core. All these things are made of ferrous material. Ferrous means not pure iron. Or this one generally it is mix of nickel, cobalt, and ferrous. Some come 80, 85, 90, and 0.5 some percentage. So that makes the magnetic strength, correct? How much magnetic field they can retain when are produced when this one is decided by the composition. So generally magnetic material, not pure iron alone, it will have nickel and it will have cobalt. And it will, so all those things will decide what you call a motor constant. Motor constant value will vary from some, it is 0 to 1. Generally, it can vary from 0 to 1 and it can multiply by some factor, correct? So that will be given by motor manufacturers after a lot of tests, but there is a formula to compute. Forget it. So Only one thing is we can, that's why I said the torque produced by electric DC motor. So this is called as the DC motor, right? Why? We are supplying two DC voltage, field voltage and armature voltage. Both are from a constant voltage from a battery or this one. Due to which there's an electrical current, DC current, IA, IF. Due to which there are pi A and pi F, two electric magnetic fields are created. These will interact with each other, repulse or attract each other, produces a motion at the armature, which is allowed to rotate, which is supported by bearings, shaft is coming out. So this is how the basic DC motor is working. Okay, I think I will stop here. Tomorrow we will see how the torque, how to calculate torque in DC motor, and what is a DC series motor, what is DC shunt motor, correct? Then we will talk about AC motor later. So one more thing I want to tell you that already we missed two classes. So those two classes I am planning to take on Thursday 5 to 7, because tomorrow professor you will have 5 to 6 another professor taking. Wednesday also some, I have only 1 hour. This Thursday I'll be taking 5 to 7, 2 hours. Be ready. Okay. For midsummers we have to cover the portion. We cannot delay.
Sir, for midsummer, how much portion, sir?
20, generally around approximately 20 hours teaching.
Right, sir. So,
Already
sir,
I think 6 hours are over, no? 5 or 6?
6 hours over.
6 hours over, yeah. So generally around 20 hours.
Sir, when is the tentative date, sir, for midsummer?
Midsummer in, because the February, March 15, 20 around that.
Sir, maybe it is better we can have it in
2020.
March 10 on the
sir,
10.
March 16 or 17, sir. That
No, that is Holy Week, sir.
or 24 you want to have it, sir.
Okay, anyhow, I need to talk with other faculty also. We have to decide. Okay, I will
Sir,
talk with them.
Sir, already that is fixed, sir, for our which one? Our Shankaram has already fixed the date.
When?
That is based on his time, and is suggested to go. We are suggested to go with 9th of March. So, if it is possible, we can have it on 24th or 15. Between 15 to 24 is okay for us.
15th to 24th. 15th March to 24th March. Okay.
Any date, sir. You can.
Okay.
Sunday is more preferable, sir.
Yeah, Sunday only. Generally, we won't put in our work. We know we make. No, I am doing for last 7 years.
We are coming directly to your workplace, sir.
Yes.
Sir, Mani sir, last time you had said that the offline exams will be considered for the internal, sir.
Yes.
Is that still? I mean, will we be still writing online, or should we come to a center?
No, not center. You will be come to IIT.
Even for internal, sir.
Internal. That's what I want to talk with the other faculties. I will come back.
Oh, okay, sir.
We will see. That's why I'm asking all the information now itself. Okay, because we need to decide. If needed, it can be proctored also. We'll see.
Okay, yeah. Online is
Yeah.
also okay for us, sir. Yeah, it based on the teams are like professors and students' decision actually.
Yeah, because we know the last time itself, the code office was asking only go to center like that only. But the NSEM definitely are going to come here. Physically, you have to come, all of you, to NSEM exam. Already decided. We are not going to TCS center. All of you need to come here and weekend and write the exams and go. Not 2 weeks, only 1 week. We will come Saturday one exam, Sunday one exam. Okay.
Sir, in the second semester, we have did. And rest of the people we attend through online. That is happened second semester. Anand sir is aware.
No, already we decided we will bring. No, this is not like that. Some people online, some offer. That is no. We want to have uniformity. So we'll see. We will see.
Okay, sir. Okay, sir.
NSEM definitely it will be offline.
Sir, everybody will come, sir.
Everybody come to IIT, you will write. That's what we have decided. I will talk to Anand. I will come back to you in 1 or 10 days. Okay.
Right, sir.
And also with
Sir,
Sankaram also. I will talk.
Sir, Sankaram already finished, sir. For us, it is finished. For them, I don't think they are not having the subject. Maybe-
Okay. Yeah. We'll see that. That's okay. No issue. I understand.
Right.
Okay.
Thank you, sir.
See you
Thank you.
tomorrow. See you tomorrow, 6 o'clock. Thursday we have 2 hours, 5 to 7. Please note that.
Yes, sir.
Okay.
Thank you.
Okay. Thank you.
Okay, sir. Yeah. Thank you,
See
sir.
you.
Thank you.
Okay. Take care.
Yeah, thank you.
Good night. Please give your attendance before leaving.